Okay, we are starting a new unit today that deals with triangles and quadrilaterals. Today we're going to talk about triangles and some segments that can be in those triangles, including medians, altitudes, and angle and perpendicular bisectors. Okay, so you did learn about some of these in Math 2. Okay, a median is a segment whose endpoints are a vertex. Okay, so the first endpoint is going to be a vertex. Well, here, a vertex. And the second endpoint is going to be the midpoint of the opposite side. If you look at your picture here, this point up top would be the vertex, and then this point down at the bottom is the midpoint. Now, if you're looking at this picture, the way to tell that that was the midpoint is these two tick marks right here. Those tick marks mean that those two pieces are equal. So your midpoint is that halfway point between that whole side of the triangle. Okay, so one of our properties, we'll talk about the midpoint. Okay, and a midpoint cuts the segment into two congruent pieces. Okay, now notice I used the symbol for congruent. Okay, hopefully you've seen that before. You should have in Math 2. One thing I want you to take note of is that a median does not form right angles. Okay, so neither one of the angles near the midpoint is a right angle. Altitudes, however, altitudes is a perpendicular segment from a vertex to the opposite side or a line containing the opposite side. Okay, we'll talk about what that means here in a second, but notice that an altitude in the description says that it's a perpendicular segment. Okay, perpendicular means that you form right angles. So this is the segment that's going to form right angles, as opposed to the previous one, the median, which did not. Okay, if you look at your pictures here, we've got three different looks for this altitude here. Okay, the first one is in an acute triangle. The altitude is inside. Okay, so we go from a vertex and we hit the opposite side at a right angle. And that blue segment inside the triangle is your altitude. In a right triangle, the altitude is a side of the triangle because we go from a vertex, and as we travel down to the opposite side to form our right angle, we're traveling along the side of the triangle. So that blue line is your altitude. Okay, the third option here is for an obtuse triangle and the altitude is outside. That's why in the description I said the altitude is a segment that goes from the vertex to the opposite side, or a line containing the opposite side. In this obtuse triangle, we're going from a vertex, and in order to be perpendicular with the opposite side, notice the opposite side had to be extended so that we could hit it at a right angle. So this is the line containing the opposite side. Okay, you had to extend the side so that you could hit it at a right angle. So yet again, that blue line is your altitude. Okay, so one of the properties of an altitude is, we kind of just talked about it, it can be outside. Here, let's put can be. So it can be outside, in, or on the triangle. Okay, the second property is that it forms a right angle. Actually, I'm going to say forms right angles with the opposite side, or a line containing the opposite side. Either way, makes a right angle. Okay, our next special segment is a perpendicular bisector. Okay, so a perpendicular bisector is a line or segment that intersects a segment, and it does two things. The first thing is that it forms right angles. Okay, it forms right angles because it says it's perpendicular. Okay, the second thing that it does is it cuts a segment into two congruent pieces. Okay, and the reason we know that is because in the name, it's a perpendicular bisector. So if you're bisecting something, you're cutting it exactly in half. Okay, so in our pictures here, this line is our perpendicular bisector. Okay, the reason why I know it's perpendicular, so it forms these lovely right angles, and it's bisecting or cutting this segment down here, AB, in half. We know that because of the tick marks. Okay, this second picture, this line is still our perpendicular bisector. But notice there's something new added to the picture. There's these pink lines. And those pink lines are there because of this third property that I'm going to state about perpendicular bisectors. Okay, points on the perpendicular bisector are equidistant to the endpoints on the segment, segment it's bisecting. So, the point on the perpendicular bisector is going to be point C here. Okay, so the point on the perpendicular bisector in my little description is point C. It says that point is going to be equidistant, which means an equal distance, to the endpoints on the segment it's bisecting. The segment that we're bisecting here is AB. So here's my endpoints. Okay, so my endpoints are A and B. And it says they're going to be an equal distance to that point that's on our perpendicular bisector. So I can say this segment here is congruent to this segment here. Okay. So what I'll say down below my property is that AC is congruent to BC. So the distance from the end point to the perpendicular bisector point is equal to the other end point to the perpendicular bisector point. So this picture specifically goes with this property. And now, an angle bisector. Okay, so an angle bisector is a segment or ray a segment has endpoints, a ray is an endpoint, and then it goes infinitely in one direction. Okay, so it's a segment array that divides an angle into two congruent angles. Okay, in our picture here, this line is our angle bisector because it is cutting angle BAC in half. I know it's cutting it in half because of these little arcs in pink here. So I know in this picture that angle BAP, okay, that's this top angle here. Here, I'll put the dot a little bit closer. It's this angle right here is congruent to angle CAP, which is this angle down below it. Okay, one of the properties of an angle bisector, besides cutting the angle in half, is that the point on the angle bisector, points on the angle, there we go, bisector, are equidistant to the sides of the angle it's bisecting. Okay, so in our picture, the point on the angle bisector that it's referring to here is point P. Okay, so point P is an equal distance to the sides of the angle. So from point P up to point B, because that's on the side of the angle, is congruent, so I can put a little tick mark. Let me make sure you can see that tick mark. Is congruent to the distance from P to C, which is on the other side of the angle. Okay, so I know that BP is congruent to CP because of this property. Okay, I've got one more property to talk about. Okay, and that is a point on the angle bisector will form right angles with the sides of the angle it's bisecting. Okay, so right angles with the sides of the angle that we're bisecting. If you look at the picture, those are already there. So from point P to point B forms a right angle, which means they're perpendicular. And from point P down to point C, also perpendicular, which forms a right angle. Okay, so let's put all of this information to use now. Okay, we've got find X if EG is a median. Okay, so let's remind ourselves what a median is. Okay, a median goes from a vertex to a midpoint. Okay, so this line is our median, and it's going from a vertex at point E to a midpoint at point G. Since point G is a midpoint, that means this segment is congruent to this segment. So I can put those little tick marks on there. We are able to set up an equation based on this information. I know those two pieces are equal, so I can say 5x minus 17 is equal to 3x plus 1. And I can solve. Subtract the 3x. We get 2x minus 17 equals 1. Add the 17. And we have 2x equals 18. Last but not least, divide by 2. So we know x equals 9. Okay, in the problem, it just said to find x. So we are done. We found x. It's 9. Problem number 2. Find x and RT if SU is a median of the triangle. Okay, yet again, a median goes from a vertex to a midpoint. Okay, so S here is my vertex, because this is our median, and U is the midpoint. Since U is the midpoint, I know these two sides are equal. So my equation is going to say 2x plus 24 equals 5x minus 30. Okay, we can subtract the 2x, and we get 24 equals 3x minus 30. We can add the 30. So we get 54 equals 3x. Hold on, let me fix my 3x. And we can divide by 3. So x is 18. And that's part of our answer, but it also says to find RT. Okay, RT is the entire segment. So we know that RT is going to be the 5x minus 30 plus the 2x plus 24. That's the entire segment from R all the way to T. So if I simplify this, we have 7x plus, just kidding, minus 6. We know what x is. It's 18, so we can plug that in. We have 7 times our x, which is 18, minus 6. So RT, if I simplify that, is 120. So x is 18, and when you plug it in to find RT, you get 120 for that whole segment. Next one, find x and EF if BD is an angle bisector. Okay, an angle bisector cuts angle in 2 congruent angles, right? Now, in this picture, we know that BD is the angle bisector. It's cutting this angle in half. So these two are equal, but that is not where my variable is. So I need to look at my other properties of an angle bisector. Okay. There was a property that we talked about that said points on the angle bisector are an equal distance to the sides of the angle. So I'm going to say point on BD equidistant to sides of angle. So the point that they're referring to on BD is this point F right here. It's an equal distance to the sides. So from F to G is congruent to F to E. FG congruent to FE. Since I know those are congruent, that's where my equation is going to come from. So 2x plus 6 is equal to 4x minus 1. I can subtract 2x, and I get 6 equals 2x minus 1. Add the 1. And you get 7 equals 2x. And divide 2. So you get x is 3.5. Okay, in the problem it says find x and EF. So we're going to find EF. If you look at the picture, from E to F is 4x minus 1. If we plug in our 3.5, 4 times 3.5 minus 1, EF is equal to 13. Problem number 4, find x and ij if hk is an altitude of the triangle. Okay, so an altitude, okay, it is perpendicular and it goes from a vertex to the opposite side. Okay, so in our picture, HK is our altitude, here's our vertex, and then this is our opposite side, and it says it's perpendicular to the opposite side. So since it's perpendicular, I know I have a right angle, which means I also have a right angle on the other side where that 3x plus 3 is. Okay, so since I know that the 3x plus 3 is where a right angle is located, I can set this equal to 90 degrees because that's what a right angle makes. Okay, to solve this, we can subtract the 3. We've got 3x equals 87, and divide by 3, you get x is 29. Okay, it says find x and ij. So find ij. If you look on the picture, from I all the way to j is adding up these two segments, x plus 8 and the x minus 9. Together make ij. So this would be 2x minus 1 if I combined all my like terms. Now I have an x to plug in, 2 times 29 minus 1. So ij, if I do 2 times 29 minus 1, it's going to equal 57 for ij. Okay, now we need to talk about the centroid before we can do these next couple problems. We're going to talk more about the centroid tomorrow, but for now, the centroid is the intersection of 3 medians. Okay, let's review what a median is really quick. Okay, a median goes from a vertex to the midpoint of the opposite side. So vertex to midpoint. Okay, some properties for the centroid. Okay, your first property is that the short part of the median is going to be half of the longer part of the median. Or, if you want to flip that around, we can say 2 times the short part would be equal to the longer part. So let me look at my picture over here. If I focus on this median, this piece from this point to point G here is going to be the short piece, right? And then from point G over here to this vertex, that's the longer part. So 2 times the short piece is going to equal the longer piece, or half of the longer piece is going to be equal to the short piece. Okay. A second property is that the short piece, so the short part, is 1/3 of the whole median. Okay, now if I want to kind of flip that around, I can say that if I did 3 times the short piece, it would equal my median. Okay, the longer part is 2/3 of the whole median. So I could think of it this way, that if I did the longer part times 3/2, it would equal my median. Okay, if you notice, 1/3 of the median, if I do the reciprocal, it would be 3. So that's why it's 3 times the short part would equal your median. In the second equation here, 2/3 of the median, if I do the reciprocal of that, that's 3/2, so that's why it's 3/2 times the longer part equals the median. Okay, so these are the same idea, just 2 different ways to write them. Okay, so if I focus on how much of the entire median these 2 pieces are, the short piece is 1/3 of the whole median, the longer piece is 2/3 of the whole median. One other thing I want to mention before tomorrow is that G is your center of gravity. So where all of those medians meet up, this is our centroid, which is the center of gravity. Now that pretty much means if you were going to balance this triangle on like the end of a pencil, that if you balanced it on point G, it would stay on the top of the pencil. It would balance perfectly because it's the center of gravity. We'll talk more about that tomorrow. Okay. Next example here, we are told in our triangle that P, Q, and R are midpoints of LM, MN, and LN. So since in our picture we're going from a vertex to a midpoint, these are all medians. Vertex to midpoint means medians. Okay, if I'm focusing on finding X, let me color coordinate this. Okay, so finding X is going to be blue. So I'm going to highlight the segment that has X on it. Okay, it's from M to R. That is a median because it's going from a vertex to a midpoint. X is on the longer piece, correct? So if I want to find the longer piece, I need to figure out what I need to do to the shorter piece, which I know is 2. If I look up here, in my first property, I know that 2 times the short piece is going to equal the longer piece. So my equation here is going to be 2 times the short piece will equal the long piece. So if I look on my segment, the short piece is 2. So this turns into 2 times the short piece, 2, equals the long piece, x. So 4 equals x. Next, I'm going to find y. So I'll focus on the segment that has y on it. Okay, notice the y is on the short piece, the y plus 1. And the long piece is 3.6. So if I go up here and look at my properties, since y is on the short piece, I'm going to focus on this first property. The short part is half of the longer part. Okay, so I'm going to say short equals half of the longer part. My short piece in the picture is the y plus 1. And we're going to do half of the longer part, which is the 3.6. So we've got y plus 1 equals, and half of 3.6 is 1.8. And then all you have to do is subtract the 1, and we know that y is equal to 0.8. Okay, and our last one here, we're going to find z. So if I highlight my segment here that has z on it, z is on the short piece. So I'm going to use the same relationship I did to find y, that the short piece is half of the long piece. Okay, so the short piece on my picture is 2z, and it's going to be half of the long piece in the picture, which is 2.8. So we've got 2z equals 1.4, and we divide by 2. And so z is going to be 0.7. Okay, next. So we are told that lines A, B, and C are perpendicular bisectors of the triangle, and they meet at point A here. Now we'll talk more about what point A is tomorrow, but just to kind of introduce it to you, when perpendicular bisectors all meet up, it's called the circumcenter. Okay, like I said, we'll talk more about that tomorrow. Okay, I'm going to color coordinate everything here. So here, I'm actually going to change the color of this. Let's just turn this to black. Okay. So finding x. If I focus on where x is, it's on a segment that's going from an end point on a segment and then meeting up with my perpendicular bisector. If you recall, let me go back to where we talked about our perpendicular bisectors. Hang on, let me find it. Okay, here we go. If we go back to where we talked about perpendicular bisectors, it's going to be property 3 here, that points on the perpendicular bisector are equal distance to the endpoints on the segment. Okay? So if I go back to my example, I know that from R to A is going to be congruent to from Q to A, which is also congruent to P A. Okay, so all three of those lines are equal. So I'm going to focus on the fact that RA is congruent to QA in order to find X. So RA's equation is 8X plus 16, and it's going to equal QA, which is 24. Okay, if I solve this, I subtract my 16. I know 8x is equal to 8. Divide by the 8, and we get x is 1. Okay, now I'm going to find y. If I highlight the segment that y is on, it is from P to A. Well, we know from the relationship I wrote up at the top there that PA is also congruent to QA. So PA, 5y minus 6, is also equal to that 24. Okay, so I can add 6. We've got 5y equals 30. Divide by 5, so y is 6. Okay, last one, finding z. Now, z is on this segment. Okay, they told me that line B, okay, that's this line right here, I'll make it kind of dotted. This line right here is a perpendicular bisector, right? I'm going to focus on the fact that it's a bisector. If it's a bisector, it's cutting a segment in half, which means this segment is equal to this segment. So to find z, I'm going to say that 7z plus 4 is the same length as that 18. Well, minus 4, got 7z equals 14. Divide by 7, so z is 2.